So in the last video we were starting to do this problem where we were writing 2 as a convex combination of these 3 points. And so generally what we're trying to do is we're trying to solve this problem where we write 2 as a, well, this is, until you put constraints on C1, C2, and C3 here, then this is a linear combination, right, of these 3 points. So this, you can't really solve it this way. I just wanted to write it here just for you to note. Okay, so what we were going to do instead of putting constraints on the constants directly is we were going to reframe the problem so that it's in terms of line segments. And so the idea was to build the line between this point A. Let's go ahead and write these points in here, B, C, D. Find the line segment between A and D, which is E, and then once you find these coordinates, you write E as a convex combination of B and C, right? And once you've done that, right, then you write D as a convex combination of E and A, right? And then you're done. So we were doing that. Point E was found to be the intersection between these 2 lines. We found those 2 lines in the last video. So in just solving, x was equal to 14/5 and y is equal to 12/5, I believe. You can double check that. Good. So now that we have point E, what we said is we want to write D as a convex combination of A and E. So let's go ahead and do that. So therefore, we want to write 2 as 1 minus lambda times 14/5 12/5. I guess I could have factored out the fifth. Oh well. Okay, 14/5 12/5 plus lambda times 0, 1. And again, it doesn't matter which direction you go here. This could be like lambda, and this could be 1 minus lambda if you want. Okay, either way is fine. I'll just go ahead and work with this. Okay, so the nice thing about this is that you can use either coordinate to solve this, right? It's easy to solve. Let's just go ahead and write down the equation that we get. 2 equals 1 minus lambda times 14/5. Right, so then let's see, what is that? 10/14 is equal to 1 minus lambda. That's, let's see, divided by 2 is 5/7. And so lambda is going to be 2/7. Good. There it is. And so now you can use the second coordinate to double check yourself. So the second coordinate would be 2 equals 1 minus lambda is 5/7 times 12/5 plus 2/7. And let's double check that. Oops. 2/7 there. Here we see the 5's cancel, right? So 12 plus 2 is 14. 14/7 is 2, and that is a verification. Good. All right. So what we have just shown then is that 2 is equal to 5/7 times E plus 2/7 times A, right? And then E itself was where? Did we find that? Did we write E as a convex combo of B and C? Oh, I don't think we did. So I still need to do one more step then. Write E as a convex combo of A, oops, not A, but B and, what point was that? B and C, 1, 3, and 4, 2. Of 1, 3, and 4, 2. Good, and so that was 14/5 12/5 equals, let's say, 1 minus gamma, just to keep our vector straight there, 1, 3 plus gamma times 4, 2. Good. Oops, sorry about that. 14/5, just take one of the equations. Is 1 minus gamma plus 4 gamma. Right, so that says 14/5 is equal to 1 plus 3 gamma. Good. Let's see, 9/5 gamma is 3, gamma equals 3/5. I believe so. Good. All right. So we can double check with the second coordinate. Is 12/5 equal to 2/5 times 3 plus 3/5 times 2. 6 plus 6 is 12. 12/5. Check. Very good. Okay, so now we're done. So now we've got 2 is equal to, let's rewrite that from the top here, 5/7 times E plus 2/7 times A, and then E was itself, sorry about that, E itself was 2/5. See if I can write that better. 2/5 times B plus 3/5 times, what was 4/2? 4/2 is C, right? And then plus A. 2/7 times A. Good. There it is. So now you've written 2 as a convex combination of A, B, and C. Whew! That was a long one. But you see that, once you've done a couple of these, I don't think you need to do any more. It's just getting used to the notation, what this notation means. So again, what we're doing then is we're expressing points as a convex combination. Like x, I could write it as the sum I equals 1 to n of like ci, say, times xi, where ci greater than or equal to 0 and the sum equals 1. Good. All right. So what we haven't done is talked about the general problem. If you can't see this picture, what do you do? Well, we won't worry about that for now. I want to encourage your intuition in 2D for now. But we will talk about this general representation later. And in fact, what's going to happen is that if we have a convex, if we have a set of points like this, the set of all convex combinations is this, for a generic C between that satisfies these, and you find out that it turns out to be what's called the convex hull of those points. Okay, and this is something that's used quite frequently in other fields. We're not going to use it a lot, but it does give us a way of representing all the points in our feasible set, because our feasible set is convex, right? Is a convex polygon, usually, if it's not unbounded. If not unbounded. And so then we should be able to write every point in the set, right, as a convex combination of our corner points. So that's the point there. Okay, I'll see you in the next video.